y equal to x to the power 3 minus 3x raised to the power 2 plus x plus 3x minus 6 at the point 6 comma negative 4. So that wastes moments over time. Let's get into it. So how do you solve this one? The first step ever that you need to do is differentiate. Remember last time we looked at differentiation. So differentiate first. So let's find our dy dx. That's the first step. So we have dy dx equal to. So to differentiate this one, remember we said we multiply the coefficient times or by the power, and then we reduce the power by subtracting minus 1. So we have 1 here is the coefficient, so 1 by 3, so that is 3. Then you reduce the power by subtracting minus 1, you are going to have 3x to the power 2. Then minus, here we have 3 by that one, that is 6. We reduce the power by subtracting minus 1, so we are going to have 1. So we can't show 1 like that. We just forget about it. Not really forgetting about it, but so we know that it is invisible, but it's there. Okay, and then we have here plus 3. The power of x is 1, so 3 times 1, that is 3. Then if you subtract x by 1 minus 1, you're going to have x to the power 0, of which remember anything to the power 0 is 1. So here we just have 3 only. Okay, and then we have the constant number becomes the 0. So this is our dy dx. So now to find the equation of the normal, after differentiating, that is now leading you to finding the what? The gradient to the tangent first. So find the gradient to the tangent or of the tangent first. So in this case we have 3x, x raised to the power 2 minus 6, okay, plus 3. So what you're going to do is, since you have the point here, this point C, you have the value of x, you have the value of y. So for you to be able to find the gradient of the tangent, so what you're supposed to do is get the value of x and replace here. So we have 2 equal to 3. Where there's x, we replace 2. So it will be 2 and then raised to the power 2. Why? Because even x here is raised to the power 2. So even the number that you're going to replace there must be raised to the power 2. Then minus 6, open bracket 2. Where there's x, we replace 2. Then plus 3. So in this case we have 3 raised to the power 2, simply means 2 by 2. You multiply 2 twice, and that will be 4. And then 4, so it will be 3. 4 by this 3, that is 12. Then minus 6 by 2, that is 12. Then plus 3. So now in this case we have 12 minus 12, that is 0. 0 plus 3, that is 3. So this is the gradient, okay, the tangent. So now in this case we can relate this topic or this concept to coordinate geometry, where you have the equations of the parallel and also perpendicular lines, where we say that the gradient of the two parallel lines is equal. Okay, the gradients of the two parallel lines are equal, but when you talk about the gradient of to the normal, it is what the product of the two gradients gives us a -1 always. So the gradients to the lines which are perpendicular, like that. So when you multiply gradient 1 by gradient 2, you get -1. So here what you have found is the gradient, the tangent, but they want you to find the equation to the normal. So find the equation of, find the gradient of the normal. So 1, so the gradient of the normal is given by 1 over dy dx. Okay. So you have negative 1 over, so dy dx is this one here. So in this case, the gradient under coordinate geometry, gradient is denoted by small m. Okay, so instead of writing like this, you can also write it as gradient 2 equal to 1 over m like that. So where is this one? Where is m1? You replace this your gradient, the first gradient that you found. So in this case, we're going to have that. So meaning this is the gradient you're going to use. So now we find our equation. Okay. Now find our equation. So let's find our equation now. So to find our equation, we use the formula. So since we have the 2 points, we have y, okay, minus y1 equal to gradient of which here can be even be represented by this dy dx, or we can use m to represent gradient. So we have x minus x1. So we have y. So where is y1, we place what we have here, and that is negative 4. So negative 4. Okay. Equal to gradient, we have this one here. To the normal. Okay. So we have 1 over 3 like that. And then x minus x1. The value of x we have is 2. So we replace 2 there. So now in this case we have y, this by that we have plus 4. So we know that negative by negative, that is positive always. Here you open up the brackets by multiplying this by this, and also negative 1 over 3 times that. So here you're going to have negative 3 x like that when you multiply that one, and then negative by negative, that is positive. Then 1 by that you're going to have, so 1 over 3, 1 over 3. This is same as 1, 3 by 2. It's like that. So it's 1 by 2, that is 2 then over 3 there. Okay. So what's next? We are not yet done. We need to make sure that y remains alone as the subject of the formula. So in this case, we collect the like terms by making sure that this positive 4 goes the other side. So we have y equal to negative. Then we have x plus 2 over 3. When positive 4 comes this side, it will be negative. Then we have y equal to 1 over 3x. So let us evaluate that. Okay, so 2 over 3 minus 4, what are we going to have? So you can evaluate this one somewhere. So we have 2 over 3 minus 4. So we do that, we find the lowest common denominator. So we have 3 itself. 3 into 3, 1 by 2, that is 2, minus 1 into 3, that is 3 by that one. So we have 12. So 2 minus 12, that is negative 10 over 3. So we now write negative 10 over 3 there. So after doing that, make sure that you check your equation if it is in standard form. Which standard form? The standard form of the equation of the normal of the straight line is y equal to mx plus c. So this is y, it being the subject of the formula, and then we have this. This is m representing the gradient, which is this part there. Then x, that x, and then constant is this one there. So meaning our equation is in standard form. So meaning we end here. This is our final